Hello, everybody. Welcome to the Learning Management System. This is Jabin Bano M. Nadaf, lecturer in Electrical and Electronics Engineering, Government Polytechnic, Belagavi. Dear all, today we will be discussing on the concept of filters. So before that, let's have a quick recap on what we have discussed in our previous class. In our previous class, we just discussed the working of the full wave bridge rectifier, the ripple factor and efficiency of the bridge rectifier, and also the advantages and disadvantages of the bridge rectifier. So let's have a quick glance on the working of the full bridge rectifier, what we had studied. So we had studied the concept of or the working of full wave bridge rectifier. This was our previous class discussion. Let's have a very short discussion on what we have studied in the previous class. We had a load which is connected between the common cathode and the common anode points. Then between the anode cathode, we were connecting the supply. So I will just draw the common cathode points. Then I will just draw the common anode points. See, between the common anode and the common cathode, what we have? We have the load resistance. The M and the L are the common anode and the common cathode points. And between the anode cathode and the cathode anode, that is the point A and the point B. This we have studied in the previous class. So we are connecting the supply. And also what was the working? The working during positive half cycle, during the positive half cycle, diode D1, D3 were forward biased and diode D2, D4 were reverse biased. Okay, so the current was flowing from A to D1. So I will mark the D1 diodes here in the circuit diagram. Okay, yeah. So during the positive half cycle of the input supply, so we have a and B. So A is a positive with respect to B. So when A is positive, B is negative, then diodes D1, D3 were forward biased and D2, D4 were reverse biased. In that condition, the current flowed from A to D1 to M to L through RL to D3, then to back to the supply. So the direction of the current was from M to L in the load resistance or external circuit, and the M was plus and N was minus, leading to the output voltage of V naught at the load resistance or V out at the load resistance. So in the negative half cycle, during the negative half cycle of supply, A is negative, B is positive. So let us go back. A is negative, A is negative, B is positive. Okay. In this condition, diodes D2, D4 were forward biased and diodes D1, D3 were reverse biased. Okay. In this condition, the direction of the current was from B to, let us go back to the circuit diagram, from B to D3. So from B to D2 to M to L to D4 and back to A. The same thing I will write. B to D2, D2 to M, M to L through the resistance RL, then L to D4, D4 to A. If you look at the secondary of the transformer, in the positive half cycle A was plus, B was minus. In the negative half cycle A was minus, B was plus. Means what? We have a bidirectional voltage or current at the secondary of the transformer. But if we look at the output, where is the output? The output will be present at the load resistance. If you look at the output of the load resistance, there is no change in the direction of the current in the positive half cycle also and in the negative half cycle also. The direction of current is always from M to L. This indicates that the bidirectional voltage or current is converted to the unidirectional voltage or current. So this itself tells that it is AC to DC. So this concept we arrived by the construction of the bridge configuration type of rectifier. So this we had discussed in the previous class, and also we discussed what is a ripple factor. Ripple factor. If you look at the output waveform of a bridge rectifier, if you have a input supply of this type, okay, this is the V input with respect to set I am, then I have a output voltage. So we have the output voltage which is DC in nature. So bidirectional voltage or current is converted to unidirectional voltage. All values above the zero axis or above the x axis. So they are all the positive values. Okay. But this rectified output, whatever it is, this rectified output contains DC and the maximum of the AC components. The amount of the AC components present is called as ripples in case of the rectified output. So how much amount of ripple is present is given by the term ripple factor, which is given by gamma is equal to the AC component of the rectified output to the DC component of the rectified output. This comes out to be 0.48, which we have discussed in our previous class. Also, we studied what is efficiency. Efficiency is the ratio of the output DC power to the input AC power. This also we have derived in our previous class, and we have got the full wave rectifier efficiency as 81.2%. Also, in the previous class, we discussed the peak inverse voltage of the diodes. All the four diodes. We know that during one half cycle, two diodes will be reverse biased. In another half cycle, another two diodes will be reverse biased. So, when the diodes are reverse biased, it means that a reverse voltage is subjected across the diode. So, in this reverse voltage, what amount of reverse voltage a diode can withstand in the reverse bias mode is called as the peak inverse voltage of the diode. The maximum amount of the reverse voltage subjected is the peak inverse voltage, and in the positive or the negative half cycle, whichever diodes are reverse biased, their peak voltage or maximum voltage was equal to Vm. Therefore, the PIV in case of a bridge rectifier is equal to Vm. Then also we studied the disadvantages and advantages of the rectifier, that is full wave bridge rectifier. In the advantages, we studied that the need for the center tap transformer was eliminated. And the center tap transformer design is a bit difficult, and even for the polarity also it is a bit difficult to identify. Therefore, we have eliminated the use of the center tap transformer. And also, the peak inverse voltage in case of a center tap transformer was 2 times the maximum voltage of the input supply. Hence, because of this, we have to use a higher rating diodes, which may become economical for us. And even the design of the center tap transformer is not economical for us. For that sake, we have eliminated the center tap transformer and we have configured the center tap circuit as a bridge type of a circuit. So, what is the main disadvantage of the full wave bridge rectifier is the use of 4 diodes. Hence, the on-state resistance drop will be a bit more, and hence the output voltage will be a bit less. We can compromise for that, and hence we can go for the configurations of the bridge rectifier. Okay, so this was all what we have discussed in the previous class. So let's quickly move towards the today's topic. The today's topic we are discussing is about the filters, the necessity of the filters, and the different types of filters. Of course, the topic is very small, but we have to understand the concept in a bit detail. Okay, so if you know what are filters, the filter circuit is a device which removes the unwanted AC components from the rectifier output, and therefore it allows only the DC component to reach to the load. As we already discussed that you talk of any rectifier, half wave rectifier you talk, or center tap full wave rectifier you talk, or you talk of a full wave bridge rectifier. So in any of these rectifiers, okay, in any of these rectifiers we have the ripple factor. So what do you mean by the ripple factor? We mean that how much amount of the AC is present inside the output of a rectifier, that is in the DC output. Our main intention to get a smooth DC, because we are talking of DC. A DC is a voltage which is constant irrespective of the time. It is not changing with time. Hence, we also have to obtain approximate this kind of the output, which is not possible in case of the rectifier, because we have a ripples and we have the instantaneous and the RMS values there, because it is derived from a instantaneous and a RMS value, a bidirectional one, which is converted to the unidirectional one. Okay, our motto or our intention is we have to remove the unwanted AC components so that a smoothing or a flattened DC is available for us. Okay, so that is the function of a rectifier basically. So if we see it here, a rectifier is just, now let us assume it is a black box which takes the rectified output as the input and gives us a pure DC at the output. A pure DC at the output. So, from where does the rectified output comes from? It comes from either a half wave rectifier or a center tap full wave rectifier or a bridge rectifier. Is it not? Yes. So, this is the basic concept of the rectifier. So, what are the elements by which we can construct the rectifier? So, the basic passive elements, what we are talking from the first semester. So, basically passive elements like the inductor denoted by L, capacitor denoted by C, or a combination of L and C. So, these are the main or basic components of the filter. ಅಂದ್ರೆ ಈ ಕಂಪೋನೆಂಟ್ಸ್ ಇಟ್ಕೊಂಡು ನಾವು ಫಿಲ್ಟರ್ ಸರ್ಕ್ಯೂಟ್ ಅನ್ನ ಡಿಸೈನ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ ಕಂಪೋನೆಂಟ್ಸ್ ಆಫ್ ಫಿಲ್ಟರ್. Okay, yes. So let us know how they are helping for us for the filtering action. ಯಾವ ತರ ನಮಗೆ ಫಿಲ್ಟರ್ ಆಗ್ಲಿಕ್ಕೆ that will be helping for us. So let us study that one. Okay, in case of the inductors, so what is the basic function of the inductor? The basic function of the inductor is, So in case of the inductor, we have studied that the inductor is a device which has the rate of the change of the current. It doesn't allow any changes in the current. Therefore, if I allow the DC to pass through it, DC is a current which is not at all changing with respect to time. So, therefore, an inductor easily passes the direct current. So, you have an inductor here. If I apply AC plus DC type of output to this, from where this output is coming for us, usually the AC plus AC component plus DC component, ಎದುರೊಳಗಿರ್ತೈತಿ AC plus DC component is always present in the rectifier output itself. It is nowhere present. Okay. So in this AC plus DC component, if I am applying to the inductor L, what is the function of the inductor? Since it doesn't oppose the rate of change of, since it opposes, sorry, I mean that since it opposes the rate of change of current, so there is no rate of change of current in case of the DC. Therefore, it allows the DC to pass through it and rejects all the AC. So, inductor basically allows the DC components to pass through them and it rejects the all the AC components. So, only DC will pass through it and AC is rejected. It is not allowed. That is the function of an inductor in case of the filtering action. Okay. Therefore, they have mentioned here it passes easily the DC. For AC, it offers the opposition and hence it drops off. Drops means it doesn't allow. Okay. That is the basic function of a inductor. Okay. So, we have to remember that if I talk of the inductor L, it allows DC, blocks AC, blocks AC. Okay, this is the part to remember for you in case of the inductor. Then only you can understand the different types of the filter. Filter design. Filters explain ಮಾಡೋ ಟೈಮಿಗೆ ನಿಮಗೆ ಇಂಡಕ್ಟರ್ ಏನು ಕೆಲಸ ಮಾಡ್ತದೆ ಫಿಲ್ಟರಿಂಗ್ ಆಕ್ಷನ್ ಅಲ್ಲಿ ಕೆಪಾಸಿಟನ್ಸ್ ಏನು ಕೆಲಸ ಮಾಡ್ತದೆ ಫಿಲ್ಟರಿಂಗ್ ಆಕ್ಷನ್ ಅಲ್ಲಿ ಅರ್ಥ ಆಗ್ತದೆ. So we have to remember it. Okay. Let us study the next component. The next component is a capacitance. So we know that a capacitance is just almost opposes the rate of change of the voltages here. Therefore, it blocks the DC components and allows the AC components because the capacitance is subjected to the rate of change of the voltage. Okay, DC ಅಲ್ಲಿ rate of change of voltage ಇರೋದೇನೆ ಇಲ್ಲ. Okay, because it is a constant voltage. But in AC we have the changing voltage. Therefore, the capacitance allows the changing voltage. It doesn't allow the not changing voltage. Which is a not changing voltage? The DC is a doesn't changing voltage. Okay. So what we have to remember in case of the capacitive component is it blocks the DC and allows AC. Okay. It is just if you look at the inductor. Okay. It is exactly opposite that of a inductor. Okay. What does the inductor tells? The inductor, what does it tells? It allows DC, blocks AC. It allows DC, blocks AC. Okay. Yes. Whereas the capacitance allows AC, blocks DC. See, it is exactly opposite as that of an inductor. Just one, if you remember, other also you will be able to do it. So these are the two elements or common elements which we are using as the filter components. We may use them individually or we may use them combination of both, or sometimes we are using them with a resistor for a certain voltage drop. So why we require filter? This is our trending topic. Okay, the topic of the today's hot topic of the today's session. So the output of the rectifier is what? Pulsating. This kind of output is called as pulsating, changing with respect to time. We know that this is the output of the rectifier which is having AC plus DC components. If such kind of output only is given to any electronic device, okay, so if we have a electronic device, so any electronic device is subjected to noise. The noise are the smaller disturbances of these kind of shapes. Okay, so it is very difficult for the electronic circuits, okay, to identify properly whether it is the output of a filter or it is something else. Okay, therefore it is very much important for us to remove the unwanted ripples from this. ಇದರೊಳಗಿಂದು ripple ಅಥವಾ AC component ತೆಗಿಬೇಕು, ಯಾಕಂದ್ರೆ that will disturb the electronic device, which is not desirable for us. Therefore the AC components are not desirable and they cannot be used for the constant electronic circuit devices. And if at all we use, if at all the circuit will recognize, then we are not getting the 100% efficiency for that particular device. Efficiency 100% ಬರುವುದಿಲ್ಲ because the type of the input what we are given is not DC for it. Okay, ಅದಕ್ಕೆ DC input ಬೇಕು, constant DC irrespective time ಬೇಕು, fluctuations ಬರಬಾರ್ದು. Okay, fluctuations ಬಂದ ತಕ್ಷಣನೇ ನಮ್ದು ಔಟ್ಪುಟ್ ಫಿಲ್ಟರ್ ಔಟ್ಪುಟ್ ಅನ್ನು ಡಿಸಿ ಇರೋದ್ರಿಂದ ನಾವು ಅದಕ್ಕೆ ಲೋಡ್ ಕನೆಕ್ಟ್ ಮಾಡಿರ್ತೇವೆ. ಆಸ್ ವಿ ಆಲ್ರೆಡಿ ಟಾಕ್, ದ ಲೋಡ್ ಮೇ ಬಿ ಎನಿ ಡಯೋಡ್, ದ ಲೋಡ್ ಮೇ ಬಿ ಎ mobile charger, the load may be a constant tube which requires, which doesn't require supply variations ಇರಬಾರ್ದು ಅದಕ್ಕೆ, just like the regulator in case of a Zener diode. So constant voltage ಇರಬೇಕು. So to obtain that we have to compulsorily remove the AC components from the rectified output. Okay, for that sake we are using the filter circuit. Okay, so what are the different types of the filters? So the type of the filters are, we may use a inductor in series, we may use a capacitance in parallel, we may use a combination of L and C called as the choke input filter or inverted L filter, or we may use a capacitor input filter also called as a pi filter. Okay, these are the various types of the filter and these types we will be discussing in our next class. So let's quickly have the few of the questions. Let me just tell the questions and students be ready to answer my questions. Okay, the circuit which removes unwanted AC components is, we have four options here. See here, ripples, rectifier, filters, none of this. So ನಾಲ್ಕು ಆಪ್ಷನ್ ಕೊಟ್ಟಿದಾರ, ನಾಲ್ಕು ಆಪ್ಷನ್ ಅಲ್ಲಿ ಒಂದು ಆಪ್ಷನ್ ಅನ್ನು ನಮ್ ಆನ್ಸರ್ ವಿಚ್ ಈಸ್ ಮ್ಯಾಚಿಂಗ್ ಫಾರ್ ದಿ ಕ್ವಶನ್. ನಮ್ದು ಕ್ವಶನ್ ಏನು, ಯಾವ ಸರ್ಕಿಟ್ ಅನ್ವಾಂಟೆಡ್ AC ಕಂಪೋನೆಂಟ್ಸ್ ತೆಗಿಲಿಕ್ಕೆ ಹೆಲ್ಪ್ ಮಾಡ್ತದೆ. A circuit which removes the AC components is. I think you all got the answer. So let me write the answer. The answer is C, that is the filter circuits are the circuits which remove the unwanted AC components. So the next question is, the elements used for the filter circuits are, option A, inductor, option B, capacitor, option C, resistor, option D, both A and B. So we all just now discussed, we are using the L inductance. We are using the L inductance, okay, for as a filter element. We are using the C capacitance as the filter element. Okay, inductance allows DC, blocks AC, capacitance allows AC, blocks DC. So what may be our answer? So think over that. I think you got the answer. The answer is D, both A and B. Let's quickly go to the next question. Which of the following does inductor allows to pass through them? So we have four options. Inductance, what it does? Inductance L allows DC blocks AC. So we have our option C as the answer. It allows the DC. So next question we will go. Which of the following does the capacitor allows to pass through them? So all we know that the inductor and capacitors are opposite in nature, their behavior. Hence, I think you have guessed the answer. So let me give the options. Option A, AC. Option B, both AC and DC. Option C, DC. Option D, none of these. The answer is A. Option A, AC. The capacitor allows AC to pass through it. So next question, what is a filter? Filter is an electronic circuit which removes. What may be the answer? ಏನು ಕೆಲಸ ಮಾಡ್ತದೆ ಫಿಲ್ಟರ್? ಫಿಲ್ಟರ್ ಸರ್ಕ್ಯೂಟ್ ನಾವು ಯಾತಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ? ಫಿಲ್ಟರ್ ಸರ್ಕ್ಯೂಟ್ ಅನ್ನು ನಾವು AC ಕಂಪೋನೆಂಟ್ಸ್ ರಿಮೂವ್ ಮಾಡಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ. This is the crude definition of a filter. So I think I have told you the answer. I guess we have understood what I have told. The answer is AC components. Filter circuits are present in tube light, mobile charger, mixer grinder, none of these. So if you quickly recall the construction of the Zener diode part what we have studied, then you will have an idea that where filter circuits are used. What is the work of the filter circuit is to provide a constant DC. LDC there. So for mobile charger, the output of a mobile charger is a DC which will charge our mobiles. So usually or unspecifically, okay, the filter circuits may be present in the mobile charger. So the answer is B. The types of filter are, see, there are 4 options. So tell me the answer. So now just we have recalled and everyone will be knowing this answer. The answer is option D. So dear students, in today's session we have discussed about why we are requiring the filter. What is the definition of a filter? Filter ಏನು? Filter ಒಂದು electronic circuit which will remove the AC components and provide the smooth DC output. ಫಿಲ್ಟರಿಗೆ ಬೇಕಾಗಿರುವಂತ ಕಂಪೋನೆಂಟ್ಸ್ ಯಾವ್ಯಾವು? ಇಂಡಕ್ಟರ್, the symbol is L. The name is L. The symbol is this one. Then capacitor is one of the component. The name is C. The symbol is capacitor. Then we are using the combination of these two. Okay. Then we are also studied about the types of the filters. Okay. So it may be a series inductor filter, it may be a shunt capacitance filter, it may be a LC filter, or it may be a pi filter. We studied the different components of, types of the filter. Also we studied what was the necessity of the filter. ನಮಗೆ ಆ ರೆಕ್ಟಿಫೈರ್ ಔಟ್ಪುಟ್ ಡೈರೆಕ್ಟ್ ಆಗಿ ಯೂಸ್ ಮಾಡಲಿಕ್ಕೆ ಬರೋದಿಲ್ಲ. ಯಾಕೆಂದ್ರೆ ಅದರ ಔಟ್ಪುಟ್ ಸ್ಮೂತ್ DC ಇಲ್ಲದೆ ಇರೋದ್ರಿಂದ ನಮ್ಮ ಲೋಡಿಗೆ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಆಗ್ತದೆ. ಆಲ್ಸೋ the unwanted noise also resembles the type of the rectifier. Hence an electronic circuit doesn't respond properly to the load. And also the DC output is expected to be a voltage which is constant with respect to time. So these all requirements tells us that we compulsorily require a filter. So dear students, thank you very much for my patience listening to this lecture. The lecture was quite small. I hope you all have understood, and the resource persons what you are looking on the screen are the persons who have successfully helped to complete the analog electronics content. Thank you one and all.